we are going to learn about mole concept. What actually is the meaning of mole? I have given the title Understanding Mole. So, what is mole? Before that, we must have come across certain words like dozen, gross, or scores in our day-to-day life. Dozen, what a dozen mean? One dozen means a collection of 12 items. We might have heard about a dozen of bananas. It means that 12 bananas. Similarly, gross means a collection of 144 articles, and scores means it is 20 items. 20 of anything is known as scores. 144 of anything is known as gross. One similar term is used in chemistry, that is a mole. A mole refers to a collection of 6.022 into 10 to the power 23 particles. So children, mole is a similar word like dozen, gross, scores, which is very commonly used in chemistry. For example, 1 mole of oxygen atoms is equal to, we can say, a collection of 6.022 into 10 to the power 23 atoms of oxygen. Or 1 mole of hydrogen, when we say 6.022 into 10 to the power 23 molecules of hydrogen. On the other hand, if we say 1 mole of sodium ions, then 6.022 into 10 to the power 23 ions of sodium. So, mole refer to simply a fixed number of particles, and the particles are generally the atomic particles, very small atomic particles. So here we should remember some points. As atoms or molecules are very small particles, hence it is very impractical to discuss the mass or volume of one atom or one molecule. Second point, a collection of 6.022 into 10 to the power 23 particle is taken as one unit. For these very small particles, it is very difficult or impractical to discuss the mass or volume of 1 gram or 1 atom or 1 molecule. Hence, a collection of 6.022 into 10 to the power 23 particles is taken. If we write this number, it will be 6022000020, which is quite a large number. So, we have already learnt that 6.022 into 10 to the power 23 numbers of any particle is taken as one unit and known as 1 mole. Now the question is, we can ask why this number is taken, this particular number. This is a difficult number. Why not 1 lakh or 10 lakh or 1 crore is taken? But we have taken 6.022. What is the significance of this number? What does it represent? So to understand this, we should know something about this number. 6.022 into 10 to the power 23 is known as Avogadro's number and is represented by n. It has been observed that 6.022 into 10 to the power 23 molecules of water weighs 18 gram, which is equal to the gram molecular mass of water. That means you can see 6.022 into 10 to the power 23 molecules of water, if you take the weight, then it will be 18 gram, and this 18 gram is the gram molecular mass of water. That means in 18 gram of water you can find 6.022 into 10 to 23 molecules of water. So from this fact we can say that mass of 1 mole of a substance is equal to its gram molecular mass of that particular substance. Let us try to understand and define mole. On your screen you can find I have written 12 gram of carbon, nothing else. 12 gram of carbon. So can you tell me how many atoms of carbon are present in 12 gram of carbon? Can anyone tell? Yes, absolutely correct. It contains 6.022 into 10 to the power 23 atoms of carbon. So, this can be called 1 mole of carbon. 6.022 into 10 to the power 23 atoms of carbon, it can be called as 1 mole of carbon. From this we can get a definition of mole. Mole is defined as the amount of any substance which contains as many particles as the number of atoms contained in 12 gram of C12. This particle, when we say, it may be atoms, molecules or ions. So, proceeding further, one diagram I want to show you to show what is actually 1 mole. 1 mole we can say it is 6.022 into 10 to the power 23 molecules or atoms or ions also. 1 mole also represent the amount of gas whose volume is equal to 22.4 liter at STP. Remember one thing, volume when we say it is only for gases, not for solids and liquids. And thirdly, we can say the amount of substance whose mass is equal to its gram molecular mass, that is known as 1 mole. Is that clear up to this? Now, we will have some example. We will discuss some example here. Question number 1 is, how many molecules of chlorine are found in 1 mole of chlorine? How many molecules of chlorine are found in 1 mole of chlorine? Second question is, how many atoms of hydrogen are found in 1 mole of hydrogen? Then third question we can see on your screen, what is the mass of 1 mole of oxygen? The fourth one, how many mole of ammonia is present in 3.4 gram of ammonia? Number 5 is, what is the volume of 0.5 mole of nitrogen gas at STP? And number 6 is, how many moles of carbon dioxide is present in 11 gram of it? So children, now if you answer this 6 question correctly, that means you understood mole concept. So one by one we will see. The first one, how many molecules of chlorine are found in 1 mole of chlorine? The answer is very direct question. This is a very direct question. The answer is 6.022 into 10 to the power 23 molecules. But the second question you can see, how many atoms of hydrogen are found in 1 mole of hydrogen? That means in 1 molecule 2 hydrogen atoms are present. 1 mole of hydrogen means 6.022 into 10 to the power 23 molecules of hydrogen. So how many atoms means double of that, 2 into 6.022 into 10 to the power 23. Third question, what is the mass of 1 mole of oxygen? Obviously it will be oxygen molecules. So the mass of 1 mole of oxygen is equal to 32. The gram molecular mass of oxygen is 32 gram. 16 plus 16. That is where the answer will be 32 gram. How many mole of ammonia is present in 3.4 gram of ammonia? Ammonia, the gram molecular mass is 17 gram. 17. That means in 17 gram, 6.022 into 10 to the power 23 molecules are present. Just you can apply the unitary method. In 1 gram, it contains 17 by 6.022 into 10 to the power 23 divided by 17. In 3.4 gram, you can find it is 3.4 by 17, that is 0.2. Then what is the volume of 0.5 mole of nitrogen gas? 1 mole of nitrogen gas, the volume will be 22.4 liter at STP. Before this we have already learned that one. So 0.5 mole of nitrogen means 0.5 into 22.4, and that is equal to 11.2 liter. And last question, how many moles of carbon dioxide is present in 11 gram of it? Carbon dioxide, we have to find out the molecular mass, and the molecular mass can be calculated to be 44. Carbon is 12, oxygen is 16 into 2, 32 plus 12, 44. So 44 gram contain 1 mole, 1 gram contain 1 by 44, 11 gram contain 11 by 44 mole is equal to 0.25. So children, some more example we can see. Calculate the mass of one atom of oxygen. We know that 1 mole of oxygen, the 1 mole of oxygen atom mass is equal to 16 gram. That means 16 gram of oxygen contains 6.022 into 10 to the power 23 atoms. So one mass of one atom of oxygen, how can you find out? It is 16 divided by 6.022 into 10 to the power 23 gram, which is equal to 2.657 into 10 to the power minus 23 gram. Another problem we will see. Calculate the volume occupied by 2.8 gram of nitrogen at STP. Gram molecular mass of nitrogen is equal to 2 into 14, that is 28. So 28 gram occupies, because 1 mole then occupies 22.4 liter. So 1 gram occupies 22.4 divided by 28. 2.8 gram means 2.8 divided by 28 into 22.4 liter. So you can see here the answer will be 2.24 liter at ST. After this, we are going to learn about another term that is known as vapor density. Vapor density the relative vapor density of a gas is defined as the ratio between the masses of equal volume of the gas and hydrogen under the same condition of temperature and pressure. What does it mean? If you take 1 liter of the gas and 1 liter of hydrogen, the ratio of their masses is known as the vapor density, or 5 liter of hydrogen and 5 liter of the gas, and we have to measure the mass of them. Just mathematically we can see it is represented as relative vapor density Vd. I have written for vapor density is equal to mass of volume V of a gas divided by mass of volume V of hydrogen, which is in terms we can say mass of 22.4 liter of a gas, mass of 22.4 liter of hydrogen, which will be equal to mass of 1 mole. 22.4 liter means 1 mole, mass of 1 mole of a gas, mass of 1 mole of hydrogen. Now we can see that mass of 1 mole of the gas is the molecular mass of the gas, and mass of 1 mole means molecular mass of hydrogen, which is equal to 2. So molecular mass of the gas divided by 2. From this we can get a formula for molecular mass of the gas. Molecular mass of the gas is equal to 2 into vapor density. So with this I am going to end this session, and today I want to give you homework from the ICSE Selena book. It is exercise 5B, question number 1 to 31. Every day, because 1 week we are getting, every day try to finish at least 5 numbers each day. So children, this is the end of the class. Thank you for watching.